The Republic of Indonesia, the world's fourth most populous country, continues to achieve stable economic growth and ranks the first in ASEAN region in terms of economic scale, whereas the coverage rate of sewerage system remains at around 12% in the capital city of Jakarta, which has a population of over 10 million. Under these circumstances, the water environment in the capital city needs further improvement urgently, and therefore the development of sewerage systems including sewer pipelines and wastewater treatment facilities are necessitated accordingly. Jakarta has unveiled the Jakarta Sewerage Development Project, which divides the entire Jakarta area into 15 treatment zones and plans to improve the living environment by installing sewerage systems in stages. Obayashi, Wijaya Karya, Jaya Konstruksi, and JFE Engineering, forming a four-company joint venture, have been awarded the construction of wastewater treatment plant Zone 1 contract. Pneumatic caisson construction is an advanced construction technology that will be introduced in this project. At first, to improve the existing soil condition, sand compaction pile is carried out. After the completion of soil improvement, sheet piles are driven around the structure. Then, the first excavation is started by excavating the ground to the working level. The next step is to install the steel cutting edge by laying it above wooden boards. Sand bedding is prepared as mold for working chamber as well as support for bottom slab casting work. Slab steel plat then welded to cutting edge. Then the construction of bottom slab can be started. Steel shafts for pneumatic caisson work also casted together with the bottom slab. Excavation and sinking phase of pneumatic caisson work will be carried out after the structure reaches structural integrity to withstand the load during construction. This structural integrity is reached after the completion of 3L floor level. Once the pneumatic caisson facilities has been established, excavation and sinking work is started. Excavation is performed by electric excavator, mounted on the ceiling of working chamber underneath the bottom slab. Afterwards, excavation and sinking and RC works are carried out in parallel. To avoid flooding in the working chamber due to underground water seepage, the working chamber is pressurized to match underground water pressure. This project will also introduce open caisson construction method. Soil improvement works by sand column is carried out. A set of ground anchors is installed to provide necessary reaction force. Then, sheet piles are driven surrounding the structure to isolate lateral ground interference to nearby area. After excavation to the working level, a steel cutting edge is installed, then the construction of first lot can be started. The casted lower structure is then pressed in by hydraulic jacks by using reaction force given by the ground anchors. Parallelly, inner side of the structure is excavated by clam shell. Afterwards, RC works, press in, and excavation cycle are repeated until the outer wall structure is completed. The verticality of the structure is always monitored. Correction and adjustment to the structure's verticality during sinking process can be made by giving the appropriate reaction forces to each hydraulic jack units. Underwater concrete is casted to plug the bottom part of the structure. Then, dewatering is carried out to dry the inner side of the structure for the construction of the bottom slab. After the completion of the bottom slab, open caisson work is finished and the structure now can be used as both driving shaft and receiving shaft of pipe jacking works. This is an illustration of wastewater plan flow process. The wastewater plan process, there are 5 main functions of treatment design: removal of oil and grease. Oil and grease will be removed at headworks through flotation in grease trap chamber between grit chamber and fine screen. Aeration blowers will be provided for aeration in the chamber so that oil and grease will be floated. Removal of organic matters and nitrogen and phosphorus. The treatment process of the WWTP will adopt a 2O, anoxic, anaerobic, and oxic, process combined with membrane process. A 2O process is so-called biological nutrient removal, BNR, and one of the most effective and economical treatment processes to remove organic matter, nitrogen and phosphorus. Removal of solid and disposal. Membrane will block suspended solids passing through. Solids are accumulated as activated sludge in the system and removed out of the membrane tank by waste sludge pumps. Removed sludge is sent to dewatering equipment units which produce sludge cake with solid contents of 17%. Dewatered sludge cake should be transported out of the WWTP for final disposal. Removal of coliform. Membrane will block coliform flowing through the pore size of which is normally less than 0.2 micron, therefore, effluent from membrane will not contain coliform. This is a process description. 5 main function of treatment design. Wastewater coming from headworks influent to anoxic tank and possible go to inside anaerobic tank for the next process. After wastewater has been processed in the anoxic tank, go to anaerobic tank. Then go to oxic tank for aerobic process. Wastewater from oxic tank flow into MBR tank through downflow. Then for effluent of MBR to the T tank and continue to cascade aerator and final discharge to Pluit pond. For biological sludge from MBR downflow to the sludge chamber. As return sludge from sludge chamber transferred to inlet A2O tank. But for waste sludge from sludge chamber will be transferred to sludge tank. Then coming to sludge treatment processing.